So the title of the presentation is very long, but the idea is how can you enhance RAG systems with knowledge graphs with open weights LLMs. And for that, I'm going to start with the table of contents is, I'm going to start first with vector-only retrieval, so a normal RAG, then a graph-only retrieval, then I'm going to combine both, and I'm going to discuss at the end about knowledge graph construction, so be patient for that. And I'm going to start with a very basic example. So I'm going to start with the data which contains the songs of Metallica, and it contains the songs, the lyrics, the album, and the artist, which is only a column full of Metallica. And the potential kind of queries that we are expecting from our users, okay, we can think of many more, but there are two types basically. One type is related to the content of the song. So for example, which song is about who is having nightmares? Anybody knows? Yeah. And the other is related more like towards the structure of the data. For example, how many songs does the reload album have, or which songs compose of this album? And there are two different kind of queries, no? And for the simple RAG or vector-only retrieval, well, the first thing I'm going to do is I'm going to create another column in which I'm going to combine the information from. I cannot show. Can I show? Yes, I can show. I'm going to create a new column here in which I'm just going to compose the album, the song, and the lyrics. So basically what I'm doing is I'm just putting it together like this. And then after I get this new column, I can put it into a vector database. So in this case, I'm using LansDB, which has some nice hybrid search and other re-rankers, etc., which I'm not mentioning here because it was outside the scope. But you should check it out. And here I'm going to use a simple embedding, so I'm using an open weight embeddings because this is the talk about open weights. I'm using sentence transformers, and I'm using just GT Tiny. And with this embedding, the nice thing with LansDB is that you can put what's the input, what's the output. So in this case, I'm putting here the text is going to be the input, and the vector is going to be the output. And with this, you can search. So first things first, so I need to first create the table and put it there. And then I can search. So for example, if I look at which song is about a boy who is having nightmares, it's going to be Enter Sandman. And normally it will give also the distance, which is in this case by default the Euclidean distance, and the vector if you want. But we don't understand this 384-dimensional vector, so good for us that these things work. And if I ask, so as I just care about the songs, so in this case I'm just showing the songs here, and I can ask the same question for another query. For example, which song is about a guy who is so badly wounded in war he no longer has any senses? So if you know which song it is, do you? One, exactly. But here it's not perfect. No, we are not in a perfect world, and it's not the first one, but it's second, so it's not too bad. But we hope, and this part is just to show. So this is if I copy the query, this should work, I guess. Who is having nightmares? In this case, it's given Enter Sandman, so that's correct. And then it's about a guy so wounded that he no longer has any senses. Interesting. Let me check. But you see, in that case, it was not that good. So. But for this query, it worked, and but it's interesting that in the other one, no. Let me see if it was void the problem, but I don't think so. No, anyway. So it's not a perfect world. Sometimes it's second, sometimes it's third, and sometimes it doesn't even appear. So that's a problem. But in general, we can use, for example, llama CPP to now go into the augmented generation part, because the other thing was just retrieval. So this is just retrieving the song. But now we want to use the LLM in order to tell us, okay, which song it is. For example, in the case, it was the second one that appeared. So it was within the context, but it was not the correct one. It was not the first one. So if in that case, I'm going to, here I'm doing most of the things by hand, because while frameworks are great for starting, at some point you want to check your prompts. and many of the things are done in an obscure way. So sometimes I prefer, even if it's more cumbersome, to look at what's the LLM receiving. So in this case, I'm just putting everything together in a text. So basically, I'm putting all the songs, and I'm telling it, I mean, not all the songs, I'm just limited to 5. And I tell it, okay, here are the lyrics. And the kind of question I'm asking, I'm going to say, okay, answer the question based only on the following context. And where I'm going to get all this text, and I'm going to put the question. So for example, here when I'm putting the question about, I think the question was this one, it should appear at the bottom, which song is about a guy who is so badly wounded in the war he no longer has any senses. It will appear the 5 songs, which were the closest one that you show, and this is what the LLM will receive. So this will be his input, and the output will be whatever he decides to. And in that case, here I'm just generating the prompt by hand, and then give it to the LLM and filtering out the response. And in that case, if I look at this, which song is about a guy who's sublimed the world, etc., he replies correctly, it's 1. And if I look, for example, to the other one, which song is about a boy who is having nightmares, he also chooses the correct one, which is Enter Sandman. And you can also check it. So basically, you can check here. Hopefully, it will not take forever. Okay, it's not bad. And here you can check also the context. So you can see that indeed it appeared in the second place. And the thing with this is, okay, this for finding song works more or less fine. Probably if I ask the question like before, it will not work. I don't know what was the issue there. But in general, it works quite okay. But if you ask structured questions, something related to the structure of the data, which for example will be how many songs does the Black Album have, it will give me 5 songs. Any guesses of why? It's 5 inputs in the context, yeah. So if I put it here, it will just normally, I hope it doesn't take forever. So here it's not running locally, sorry to disappoint you, but it's running, I'm using Open Router to do this, but I am running locally for doing this. This is a notebook. So here indeed it says the same thing, so I'm just giving it this 5. He also adds that in reality it has 12 because he knows, but in general, given that I'm providing most of the, in my cases, I'm providing internal documents, you don't want them to be doing something crazy. So that's not what you want. Hopefully this motivates to, okay, there should be another way, and probably complementary way. And actually I can check that indeed there are more than 5 songs. So this is just filtering out the album. And I could also think, okay, let's think about the structure of the data. I'm going to put it as a graph. And in this graph, I'm going to use Kutsu. So Kutsu is another, so it's a graph database. It's quite permissive license. And like Neo4j, I mean, Neo4j is great, but Kutsu has many other perks. So you should check it out, and you can use, you can generate as many. It's on disk, so all the database is on disk. And here I'm just going to, the way you input data is you create a schema. So it's not rocket science. You create the schema for the artist, for the album, for the song, and then you create the edges, the schema for the edges. In this case, it's going to be in album, and from which artist is each album. So in this case, the structure of the data is quite clear, but for the graph construction part I'm going to speak, it will not be. And here you can basically input the artist, the albums, the songs, and you can input similarly at the edges. So for me, the edges will be the song to which album does it belongs to, and the album from which artist it is. So if I can run here, so this is what you obtain. So this is more or less what you obtain. Here is the group. So it's Metallica. Here are the albums. For example, the Black album, and there should be the songs. Let's see. Let's search for one that it belongs to. Okay, this one. So in this one, I need to select with the mouse. You will see, okay, this is the song, and here are the lyrics. And this is on disk. As I mentioned, it's MIT license. And you can, if I can, you can also make queries. So, for example, if I search for, so this is the language they use. It's Cypher, same as Neo4j. Ah, okay, demo time. But yeah, demo time. Sorry, but normally it works. And you can check which will be the songs which belong to that particular album, and it will just show those ones. Okay. So once you have input the data, now you can make this kind of query like I mentioned, and you can get the responses. So getting the response is quite, it's similar. So you need the problem is you need to know this Cypher language, and that's a problem. But that's why we have LLMs, no? You don't need to you don't need to make these complicated things anymore. So I'm going to use, just because if I use a local model, this will not work. I know, because I tried. So what I'm going to do, I'm going to pick up the traces from a big model, take the prompt, put some examples, and then run locally. So I'm using with here to get the traces. As I mentioned, I'm using OpenRouter just to the model I'm using here under the hood is Llama 3.1, but the big one, 405. And I'm just going to create through LangChain, so I'm not going to use LangChain at the end. I'm just going to pick up their prompts. And if I run this chain, I get, for example, here the correct answer. So LangChain generated the correct prompt in order for me to get this nice Cypher query. And with this Cypher query, I provided to the context to the LLM again, and I said, answer me nicely, and he provides the nice answer. Okay, and if I try another one, for example, here, to be honest, I know why it made that mistake. Okay. Yes, so here the Cypher query he generated was wrong because he misses the part of the album here. He should have put album and then what's the album name. Therefore the context he look at, it's empty and it doesn't work. So you say, okay, graph, let's throw it away. But in reality, no. You can take out their prompts, and this is what, for example, here. You can look at it. So here, this is the first prompt they use. So if you look at the prompt, there is nothing mysterious. The only thing that they do at the end is they add this the query, and before here they added the schema. So it's not rocket science. And then the second one thing they do is once they get the answer, they said, okay, answer nicely. So follow this example when generating answer. etc., etc. So you can filter these two prompts, and this is what I did. And so just copy paste it. Here I provide the schema, here I provide the user query, and I provided an example. So for example, which song does the load album have? Because I know that this will not work without providing some example. And here is the second one, which I just copy pasted. In this one I didn't modify anything. I just provide the prompt. And once I get the prompts, I can run it locally. So now I can run it locally. I just generate the prompt, the first prompt. I generate the cipher response, the cipher query. I get the cipher query, and then I run it. And after I run it, I just run the second prompt. And so there is nothing, hopefully nothing mysterious here. And once you can do that, you can run it locally. This is how many songs does the Black Album have? Which song does the Black Album have? And okay, here again, I'm tricking you because this is running not locally, but this is the answers that I get from the local one. So let's see which songs. Let's try which songs. So the visualization I'm doing is by Solara, which has a presentation later. And you see, this is the answer it provides, and here is the cipher query generated. So it's working, I would say. It still make a few mistakes. For example, I think that, for example, if I ask the albums, which albums, how many albums, let's say, how many albums does Metallica have? I think this was making mistake, which means that I have an opportunity. No, it generated correctly. Okay, but if it sometimes you find an error, you have the prompts, which means that now you can input them in your examples, and you can run it locally without having to depend on some framework, and without having to run it somewhere else computer. Okay, and now the final thing is, okay, this is a very simple case, so I know it's not the most sophisticated case of graph RAG, but how can you combine it? In this case, you could have, here I'm just doing a classification, and for that I'm just generating a prompt. This I could do apply chat template by transformer, but I'm doing it myself because again I like to look at my prompts. And here I'm using outlines, which was mentioned already in the first talk, which is to force the model to answer only two, for example, in this case, only two options, yes or no, because otherwise the model will start saying, base it on according to the and then he will give the answer. And then you will need to filter out and do regex and everything. Here you just need to say, okay, these are the two options, give me what's the answer. And indeed, you see that if I ask the question to this, it classifies correctly. Okay, this is a very limited number of samples, but it answered correctly the queries, so it seems to be working. And then if the answer is yes, then I'm going to generate one type of answer. If the answer is no, I'm going to do to the knowledge graph answer. And that works reasonably well. You can see here that for each query, here this is the query, and then I'm getting the response. So the first one is related to enter Sandman. The second one is related to 1. The third one is how many songs. So here is generated a cipher query. And here it's also related to which songs does it have. It will search in the graph which are their neighbors, and therefore it will provide a question. Yes, so if in the case, for example, perhaps I could take one of these songs already, which is already. And if you look here, this just classifies. So in this case, it has already one question, which is, how many songs does the album have? And I could ask the same, which songs. It will provide a cipher query. And this is the cipher query generated, and here is the answer. And I could do the same with a query which is related to the content, and here is the content, and here gets the answer, and here's the context that he look at it. So you see it is in the context the question. So this works fine. And I think the other thing is, okay, but the albums is a very simple example because the graph is already known. So you want to construct this. So how do you do that? And here I'm again using outlines just to show a basic example here. You can generate graphs on the fly. Let's see if I have this text will do, I think. And the way you can build this, okay, in this case I'm using, as I mentioned, I'm tricking it here because I'm not using the local model, but you can use the local model. So here, for example, I'm taking just one text related to Marie Curie. And when she came to the US, well, she didn't came here, but she went to the US. And she met Pierre Curie, etc., etc. And then I'm going to use outlines again, because I want to force, so in the previous one I didn't force anything. I just said, build me a knowledge graph, I'm going to take care of it, and then I just show it, display it. But here I want to filter with particular node types and particular edge types. So here I can specify which kind of node type I want, which type of edge I want, and then after I get this from the PyData schema, I can provide this PyData schema. I can say, okay, you need to generate a knowledge graph. So you need these three components, nodes, edges, and knowledge graph. And with this, you just say, okay, here is the prompt. Sorry, I need to give a prompt. I could do it. And here is what the model outputs. So it provides all the nodes and the edges. And if you want to look at it in a more beautiful way, it's I'm just using GraphViz here to show, okay, it provides, sorry. It provides a reasonable graph. To be honest, I was expecting more content. So the trick here is how do you cut it also. So in this particular case, I just provide the whole text. But normally for a local model, I will cut it in much smaller pieces and just can generate a smaller graph. And then the fusion part is the complicated part. But it works reasonably well, I would say. So conclusions, our goal in RAGs, it's basically we need to provide what's the better context to the LLM. I'm not saying the best because it's impossible, but the better content prior to generating its response. Combining graph and vector retrieval help us to achieve this goal. So in the case of vector, you look semantic search, and in the case of graph, you look at more like the structure. And for example, you can search what are the neighbors of, or the neighbors of the neighbors of a certain entity. And knowledge graph, thanks to structured outputs, allows to constrain the node types and the edge types. So it's it really helps in the construction of a knowledge graph. And here are the references. I recommend you to follow Thomas, who works at Neo4j. He's really, really good. This is the example of the song is coming from Christopher Bergman, in which case he's using Neo4j, but I wanted to do everything myself. Prasant Rao is the person who works at Kusu and who is very active, and he has many related to GraphRag strategies. And here is the stack I use, which is LansDB, Kutsu, LlamaCpp, Outlines, LangChain, and Solara for the visualization. And LangChain, in reality, I basically copy-pasted their prompts. That's it.
Thanks a lot. I think everybody wants to listen to Metallica now. But before, if there's a question, I think we have 5 minutes to take some.
Hi, Hi, thank you for the presentation. My question was about how you decided to use Kuzu. Was it because you wanted to try it out, or did you have any preconceived idea of what the difference would be compared to Neo4j? And in any case, I mean, after using it, what would you say the pros and cons compared to Neo4j are?
So Neo4j, the problem was that it was restricting to one database, or basically this is what the problem I was encountering. Installing it was also very hard because I have to install it in the server, and it was not compatible. I had a lot of problems. Kutsu is pip install Kutsu. You can do as many databases as you want, and I will say the cons is that in this Thomas Bratanis is Neo4j, which means that a lot of things he has done are work very well at Neo4j, and Prasant is very good as well. But let's say that Thomas has pushed a lot the generative AI part, and there are things that I still cannot do in Kutsu that I would like to do. I think they are coming, but this is the counterpoint.
Hello, thank you for the presentation. I have one question regarding the combination of vector and graph.
Yes.
In the graphs, in the nodes, had the attributes of the contents of the lyrics. So when you asked about the contents of the lyrics, it could theoretically go into the graphs and search for them. Why do you rely on vector database anyway? Is it something because it's cheaper also, or is it more difficult to do it in the GraphDB?
Good question. No, my claim is that so for finding nodes and relationship, I think that graph is the best. But for finding semantic, I will still rely on vector. So I don't think that graph. I think so. For example, in the graph RAG strategies, he also of Prasant that I'm pointing out here. He also tries graph only, and he also came to the conclusion that I think we need both. And I also tend to think that for semantic search you need the vector, and for entity and looking at neighborhoods and looking at neighbors of neighbors, etc., it's graph.
Any other question?
Thank you for the presentation. My question is regarding complex schemas. How do you embed a graph database with hundreds of nodes? We saw one with 3 nodes only. That was already sort of struggling.
You mean the fusion of nodes, the fusion of graphs? Sorry.
Yeah.
This is again, Thomas Bratanis has a great blog post about fusion of graphs, and but the strategies are relatively what you can imagine. It's semantic search combining things that are similar in meaning, but you define a threshold at which they are similar in meaning. The keywords, if the words are similar by 2 letters, but why not 3 letters? So, but again, this is a little bit the problem is how do you build a good knowledge graph? And yeah, this is the best answer I can give you for the moment is this. I think that this is the best strategy for the moment.
We have time for one last question. Sorry, it's going to be the first.
Yes, thank you for the talk. Yeah, I was wondering, it's also possible in your metallic example, for example, it was like a perfect your data. Sorry, it was structured like a proper table, right? It was pretty clean. So you could have generated like you could have asked an LLM to generate an SQL,
yes,
a SQL query, and then run the query on the table.
Yes.
So it's something that you didn't show here.
True.
Is it because in graphs are more flexible for like different types of links between nodes and stuff like that?
Yes, so I think that definitely in this example you could have done it. I guarantee 100% that this should have worked. I think that the kind of example in which SQL is more complicated is when you are looking at okay, I want to look at between, I don't know, the third neighbor, and you need to start doing joins and or between the third and the fifth neighborhood, etc. So these kind of things, for example, for financial transactions, this kind of thing for graph is very simple, straightforward to do a cipher query with this kind of question, while for SQL you will need to start doing joins, and it will be a mess, and probably the LLM will completely fail. But yeah, for this example, I guarantee that SQL could have worked perfectly. Yeah.
Thanks.
Thanks, everybody. We can thank our speaker again.